So in this lesson, we're going to be using all the methods that we have right now to solve systems of equations, which include graphing, substitution, and elimination. And we're going to look to see what type of systems lend themselves to each of those ways to solve those systems the best. So solving systems of equations, let's go ahead and get started. Here's a first example, story problem. Tickets to the school play are $5 for adults and $2 for students. If there were 350 tickets sold and $1,150 were collected, then how many adults and how many students went to the play? So what I'm going to do here is I'm going to have our X be the adults and students be Y. And the first thing we know that there were 350 people that went to the play. Well, that means that if you take all of the adults plus all of the students, those add up to 350 people altogether. Well, we also know that the play brought in $1,150, and so that would be $5 for each adult plus $2 for each student. And if you add those values together, the number of the amount of money brought in by the adults and the amount of money brought in by the students, that added up to $1,150. So here's our system of equations, and what we're going to do is solve this system using any method that we want. And so because both of these equations are in standard form, it might be easiest here for us to use elimination. And so in order to use elimination, I am going to take this top equation here, and I'm going to multiply this whole thing by -2. That way my y's are going to end up being eliminated. -2 times x is -2x. -2 times y is -2y. And 350 times -2 is -700. So now when I take these two equations and I add them together, 5x minus 2x is 3x. My y's are eliminated. And then 1150 minus 7 is $450. And so then I can solve for x. All I need to do is divide by 3. And if I divide by 3, then x is equal to 450 divided by 3 is 150. Well, that means there were 150 adults that went to the play. But I still need to figure out how many students went to the play. And so I'm going to take this top equation here, and I'm going to plug in 150 for x. That's 150 plus the y equals 350. Well, if I subtract 150 from both sides, I'll get that y is 200. So that means there were 200 students that went to the play. So there's an example of solving a system using elimination. Let's take a look at example number 2. Richie has $200 saved up, but spends $5 per week. While poor Johnny only has $32 saved up, but he's saving $3 per week. So the question is, in how many weeks will the two of them have the same amount of money? And how much money will both of them have at that time? And so let's write an equation here first for Richie. Richie, right now, if we take his money, he spends $5 a week, so his slope is -5 times x, plus he's starting off with $200. And the reason it's negative is because he's spending $5 each week. And then there's poor Johnny over here. We're going to write an equation for him as well. Johnny, his amount of money, he is saving $3 per week, so that's a positive 3x, and he starts off with $32. And so here is our system. And for this one, because I have y equals something, I am going to use the method of substitution. And what I'm going to do is take this right here, which is equal to y, and substitute that in for this y here. So in other words, I'm going to have -5x plus 200. That's y, and that equals 3x plus 32. So I'm going to start by adding 5x to both sides. And if I do that, then I'm going to have 200 equals 8x plus 32. But then I'm going to subtract 32 from both sides. So I'll have 200 minus 32, which is 168. And that equals 8x. Then if I divide both sides by 8, I would have x equals 21. So x was the amount of weeks that go by, and so the answer to the first question, how many weeks will they have the same amount of money? Well, that's going to be 21 weeks. But then the second question is, how much money will both of them have at that time? Well, I would plug 21 into both of those equations. And so, for example, if I plug it in here to this equation, 3 times 21 is 63, and 63 plus 32 is $95. And that should be the same thing as if I were to plug it in here. Negative 5 times 21 plus 200 would also give me $95. Both people will have $95 after 21 weeks. And that is an example of solving it using substitution as our best method, because we had y equals something already. So let's take a look at these two examples. What method would we use in number 3? And if we look at number 3, because we have y equals this expression, I would probably use substitution and just stick this expression in here for y. So if I rewrite the second equation, it's going to be 2x plus 3y. But I'm not going to put y there. I'm going to substitute what y is equal to, which is 3x minus 2. And that equals 27. So now, to solve this equation, I would have 2x plus 3 times 3x is 9x. 3 times negative 2 is negative 6, and that equals 27. 2x plus 9x is 11x. Minus 6 equals 27. If I add 6 to both sides, I'll get 11x equals 33. And if I divide by 11, x is 3. Not finished yet, because even though I know what x is, I still need to figure out what y is. But I can do that using this equation here. I know that x is 3, so it's going to be 3 times 3 minus 2, and that's what y is equal to. Well, that's 3 times 3 is 9 minus 2, and that means y is 7. And I could check by plugging both my x and my y into those equations to make sure that they are true expressions. Well, let's take a look at number 4. I would pause the video, try number 4 on your own, and then see if you do it the same way that I'm going to do it. So if it were me, I would use elimination here because I don't have x equals or y equals. I could use substitution, but I think it's going to be easiest to either eliminate the x's or to eliminate the y's. And I don't think it matters which one we choose. I think I can eliminate the x's by multiplying the second equation by negative 3. But I think what I'm going to do is take this top equation here and multiply it times negative 3 so that I can eliminate my y's. So if I do that, 3x times negative 3 is negative 9x. 2y times negative 3 is negative 6y. 8 times negative 3 is negative 24. And then when I add these together, a positive x minus 9x is negative 8x. My y's are eliminated, and a negative 8 and a negative 24 is a negative 32. So then I can figure out what x is by dividing both sides by negative 8. So x is going to equal a positive 4. I'm not done yet, though. I'm going to take this top equation here, and I'm going to plug 4 in for the x. So instead of 3 times x, it's going to be 3 times 4, which is 12, plus 2y equals 8. Well, to figure out what y is, I would subtract 12 from both sides, and I would get 2y equals negative 4. And if I divide by 2, y is negative 2. And I could write it like this, and I probably should go back and plug an x and a y into both of my equations because I want to make sure that they both work. Let's try one more example. So here we have y equals 2x minus 7 and y equals negative x plus 8. And here again I have y equals a number. So I'm going to use substitution here, and I'm going to take this 2x minus 7 and substitute it in here for this y. So if I rewrite the second equation, instead of y, I would use 2x minus 7 equals negative x plus 8. And if I add x to both sides, then I would have 3x minus 7 equals 8. If I add 7 to both sides, it's going to be 3x equals 15. And if I divide by 3, x is 5. Then, let's say I take this equation here, and I substitute a 5 in for x. Y is going to be negative x, which is negative 5 plus 8, which means y is 3. That's what we're going to be working on for our homework. You can use substitution or elimination or even graphing if you wanted to solve these systems. And we will talk more about this tomorrow in class.